In this session, we're going to talk about the binomial theorem. Now, we're going to talk about the Pascals triangle. But before we talk about the Pascals triangle, let's introduce the topic. What are you supposed to know? Okay? So, there's something that we call a monomial. A monomial. A binomial. A polynomial. Now, these are Greek terms. Okay, so like mono just to mean one, right? Then nomio just means a term. Okay, so a monomial is an expression that only has one term. Let me say an example. Let me say 2x. Okay, let me say 3y. These are single terms. Okay, these are monomials. But a binomial, in this case, because bi means two, it will be an expression that has two terms. Let me say 2x plus 1. This is a binomial. Okay, let me say 3 plus 2. Okay, this is a binomial. Okay, now a polynomial, now this can be 3 or more. Okay, you can have 2x plus 1 plus maybe y, or even other expression plus z if you want. So these are polynomials. So it is very important that you understand this basic. Now we're talking about the binomial expansion. So if you're going to put a power to it, it now becomes an expansion. So it is very, very important for you to know. So that's what we're going to be talking about in this session. Now I must make mention something very clear, is that in as much as we are expressing, or let me say solving the binomial expansion, sometimes the power can be so big that it will be so tedious to use an approach. Let me say you have 2 plus x, then this is squared. Okay, this won't really require a lot. You're just going to get 2 plus x, multiply it by itself, 2 plus x, then you solve. Okay, like that. So this won't be that much. Okay, so for small powers, we are going to use the Pascals triangle. Okay, for small powers. But for bigger powers, which will make it very tedious for us to be multiplying those ones, hence even there's a high chance of making mistakes. So let's say maybe you have 2 plus x to the power, let's say 100. Okay, how are you going to solve such a one? So for this one, we're going to be using the binomial theorem. But for simpler powers, we're going to be using the Pascals triangle. Okay, so what about the Pascals triangle? Okay, okay, so let's draw the Pascals triangle. So let me say this is one, this is another one. Okay, so I'll be adding ones like that. Okay, so what are we going to do? If I add this one and this one, they'll give me a 2. So I'm going to write it there. I'm going to write it in the middle here. Okay, now if I add 1 and 2, that will give me a 3. A 3, I'm going to write it there. Now again, if I add 2 and 1, that will also give me a 3. So I'm going to write a 3 there. Now if I add 1 and 3, that will give me a 4. So I have a 4 there. If I add 3 plus 3, that will give me a 6. I'm going to write my 6 here. If I add the 3 and the 1, that will give me a 4. I'm going to write my 4 there. Okay, let me also put the last ones. Let me put a 1 here and at the very far end, like that. So now if I add 1 and 4, I'm going to get a 5. So allow me to write it here. Then if I add 4 plus 6, that will give me a 10. So allow me to write it here. If I add 6 and 4, that will give me a 10 again. If I add 4 and 1, that will give me a 5. So this is the Pascals triangle. Okay, so I've come up with a triangle. Now these numbers that you're able to see in this case, they represent the coefficients of a particular expansion. Okay, so you have to understand that. Now let's have an example using the Pascals triangle. Let's say they've given you, let's say 2x plus let's say just okay, let me say 2 plus x to the power, let's say 5. Okay, then they've asked you to expand this binomial expansion using Pascals triangle. Now look at the power. The power is a 5. Okay, so if the power is a 5, it means we are going to go in the row 5, and those are the coefficients that we are going to be putting. Okay, these ones. So the coefficients, you have 1, you have 5, 10, 10, 5 and 1. So those will be the coefficients of the expression that we are going to have. Okay, so let's do that. So the coefficients, we are saying we have 1, we've got 5, we've got 10, we've got 10, we've got 5, and we've got 1. So these will be the coefficients of the expressions that we're going to be having. Okay, so let's start. So let me start with 1. Okay, so 1, that is our first coefficient. Now this 1 is going to multiply by the first term, which is 2 in that case. So it's going to multiply by 2. But now this, it will be to the power 5. Okay, plus we come to the second coefficient. The second coefficient is 5, so I'm going to write my 5. Then we are multiplying this by what? By 2 again. You're going to get your 2. You're going to get your 2. Now your 2 in this case is going to drop by a power, so it will be 2 to the power 4. Then you introduce x. Now this x, it is going to have a power of 1. Make sure that the power, as the powers of a constant are reducing, the powers of a variable or a letter should be increasing. And make sure that the powers are always the same. The power is 5. Make sure that the powers are always adding up to 5. We come to the second coefficient. The third coefficient is 10. This is multiplying by, we are saying it's multiplying by 2. Now 2, now it will be to the power what? It will be to the power 3. Okay, it's going to reduce by 1. Then x is going to be to the power 2. Okay, now we come to the other expression. Now we've got another 10, so I'm going to put a 10 here. I have 2. I'll have 2 to the power 2 now. Then I have x to the power 3. Okay, then I'm going to also write the other one. I've got 5. So 5 is another coefficient that we have. This 5, what am I going to now have? 5, it will be multiplied by 2. Now 2, now to be just 2, just the way it is, because it's to the power, now it's to the power 1 multiplied by x. X now to be to the power 4. Then allow me to write the last one down here. The last one will just be x to the power 5. So now that we've done that, what we just need to do is now to simplify what we have. Okay, so I've got 1 multiplied by 2 to the power 5. 2 to the power 5 is just a 32. So I have a 32 plus, I come to the second term, 2 to the power 4. That is like 4 plus 4, 4 that's 4, that is 16. 16 multiplied by 5, that is like 80. So I have 80x. I come to the third term, so I've got 2 to the power 3, that is 8. 8 multiplied by 10, that is 80. Now remember, I've got an x there, so I'm going to, there's x squared plus, then I've got 10 multiplied by 2 squared. 2 squared, that is a 4. a 4 multiplied by 10, that is like a 40. Then I've got x to the power 3 plus. Then I come to the other one, 5 multiplied by 2. 5 multiplied by 2, that is just a 10. Then I've got x to the power 4. Then the last expression is x to the power 5. So this is expanded version of x 2 plus x to the power 5 if you're getting, the coefficient with the power of 5. Okay, so this is how we solve if your power is small. Then in the next session, now we're going to talk about the binomial theorem, where now we're going to be dealing with bigger powers. Okay, thank you.